Have you ever really thought about it? Like, what are you made of? What about your phone? Or the stars? It turns out it's all the same basic stuff. And today, we're going to dive deep and figure out what those fundamental building blocks of, well, everything actually are. Let's do this. All right, but before we get into the nitty-gritty, let me ask you something. Picture this. You're holding a solid piece of metal, just holding it in your hand. Do you think your own body heat could be enough to melt it? I mean, really, turn it into a liquid puddle right there in your palm. Sounds like something out of a superhero movie, right? Well, believe it or not, it is 100% real. Say hello to gallium. This stuff is a solid metal, looks kind of silvery, but it has this incredible secret. Its melting point is super low, just under 30 degrees Celsius. Your hand? It's way warmer than that. So yeah, just the heat from your body is all it takes to turn it from a solid into this amazing shimmering liquid. And this awesome little party trick, it's all thanks to the properties of something we call matter. That is the big idea for today. Gallium is just one really cool example of this stuff that makes up absolutely everything. Okay, so let's get right to it. The huge question, what is everything really made of? We're about to basically peel back the layers of the universe and see what's going on at the very, very bottom. So here's the scientific definition, but it's actually super simple. Matter is just anything that has mass and takes up space. It's not some far-off, complicated thing. It's the food you ate for breakfast, the air you're breathing right now, and yeah, it's even you. You are made of matter. Okay, so how do we even begin to organize all this stuff? Well, scientists like to split matter into two big groups to make it easier. You've got pure substances on one side and impure substances, which we usually just call mixtures, on the other. So let's figure out what that pure part really means. We're going to start with the pure stuff. I'm talking about the most basic, fundamental building blocks you can possibly imagine. It's time to meet the elements. So what is an element? It's a pure substance that's basically the end of the line. You can't break it down into anything simpler with a chemical reaction. The best way to think about it? Imagine the whole universe is made of Lego. The elements are those individual single Lego bricks. You just can't break a Lego brick into a smaller Lego brick, right? It's the simplest piece you've got. So how many of these ultimate Lego bricks do we have to play with? Right now, we know of 118 of them. You know some of them for sure, like oxygen and iron, stuff you find all over the place. Others are super rare and have only ever been made in a lab. But here's the mind-blowing part. Every single thing, and I mean everything, is built from some combination of just these 118 elements. Okay, you've all seen a periodic table, right? And you've probably wondered, why is the symbol for gold Au? It doesn't make any sense. Well, here's the secret code revealed. A lot of the symbols come from their old-school Latin names. Gold was aurum, so Au. Iron was ferrum, so Fe. It's a pretty cool little history lesson hidden right there in the table. All right, so we've got our Lego bricks, the elements. But a big pile of bricks isn't very interesting, is it? The fun part is building with them. And when we start chemically clicking these elements together, following a set of instructions, we make something totally new. We make compounds. So a compound is also a pure substance. But here's the difference. It's made of two or more elements that are chemically stuck together. And there are two super important keywords here, chemically combined and fixed ratio. This is key. It's not just a random pile of bricks anymore. It's a specific model built from a blueprint. And here's the perfect example. Let's build the most famous compound there is, water, H2O. The formula, H2O, is literally the blueprint. It's a recipe that says, take 2 hydrogen atoms and 1 oxygen atom, snap them together with a chemical bond, and boom, you've made water. But how important is that fixed ratio part of the blueprint? Well, it can be the difference between life and death. Seriously. Look at H2O. That's water. We need it to live. Now, let's just add 1 more oxygen atom. Just 1. The blueprint changes to H2O2. That's hydrogen peroxide. You know, the stuff you use to disinfect cuts or bleach things. That one tiny change to the recipe creates a completely different thing with totally different properties. So yeah, that fixed ratio, it's everything. Okay, so that's the world of pure substances, elements and compounds. Now let's jump over to the other side of the chart and talk about the impure stuff. Let's talk about mixtures, where things are, well, just mixed together. A mixture is pretty much what it sounds like. It's when you have two or more things physically mixed, but, and this is the important part, they are not chemically bonded. They're just kind of hanging out together in the same space. The best example, a fruit salad. You've got strawberries and blueberries in the same bowl, but the strawberry is still a strawberry. The blueberry is still a blueberry. They didn't magically combine to form a strawberry. And mixtures come in two basic flavors. First, you have homogeneous mixtures. Homo means same. So these are the ones that look the same all the way through. Think about salt dissolved in water. You can't see the little bits of salt anymore, right? It's a uniform mixture. Then you have heterogeneous mixtures. Hetero means different. These are the chunky ones where you can see all the different parts, like sand and water or, a chocolate chip cookie. All right, talking about this stuff is great, but let's see it in action. We're going to do a little showdown, a classic experiment to really nail down the difference between a mixture and a compound. We're taking two elements, iron and sulfur, and we're going to see what happens when we combine them in two very different ways. First up, we're just going to dump them in a bowl and stir them up. So we've got this yellow sulfur powder and these gray iron filings. This is a mixture. The iron hasn't changed, right? It's still iron, which means it's still magnetic. So I can take a magnet, stick it in the bowl, and poof, all the iron filings jump right out. We can separate them easily because they were just physically mixed. But now, let's change the game. We'll take that same mix and add some heat. That energy kicks off a chemical reaction. The iron and the sulfur atoms actually bond together, and they form a brand new substance called iron sulfide. This is a compound. And check this out, the properties are completely different. If you put a magnet near it now, nothing happens. The iron isn't magnetic anymore because, well, it isn't iron anymore. It's part of a whole new thing. So let's just quickly wrap up what we saw in that showdown. A compound, that's formed chemically. A mixture, just physically stirred up. In a compound, you get brand new properties. In a mixture, everything keeps its own properties. And the big one, you can separate a mixture physically with a magnet or a filter, but to break apart a compound, you need a whole other chemical reaction. Now, just when you think, okay, I get it, science always throws a curveball. Because what we've been talking about is amazing, but it gets even weirder. In the last century, scientists like Louis de Broglie figured out that when you get down to the super, super tiny subatomic level, matter starts to act strange. Like a particle can also behave like a wave of energy. It's a seriously mind-bending concept, and it just goes to show you there's always a deeper level to this stuff. So why should you care about any of this? Because this isn't just stuff for a test. It's happening all around you, all the time. When you cook, you're making mixtures and causing chemical reactions. That phone screen you're staring at, it's made from a super precise arrangement of different elements. Learning about this stuff, it's like learning the secret language the whole universe is written in. So, I'm gonna leave you with a challenge. The next time you pour yourself a drink, or watch something bake in the oven, or even just take a breath, stop and think for a second. What am I looking at? Is this an element? A compound? A mixture? Now that you know the rules for how everything is built, what are you going to see differently? Thanks for hanging out with me.